Let's do problem number 62. A block of mass m equals 2 kg is released from rest at h equals 0.5 meters above the surface of a table at the top of a angle theta equals 30 degrees incline shown in the figure. The frictionless incline is fixed on a table of height h equals 2 meters. A. Determine the acceleration of the block as it slides down the incline. B. What is the velocity of the block as it leaves the incline? C. How far from the table will the block hit the floor? And D. What time interval elapses between when the block is released and when it hits the floor? And E. Does the mass of the block affect any of the above calculations? Okay, let's draw our diagram. So we have the block up at the top of the incline. Since this is an incline, I will tilt the axes. So down incline is positive x and up is positive y. The components of the weight will be, they gave us theta to be 30 degrees, but we'll leave it in theta for now. X component is mg sine theta, and the y component is mg cosine theta. They tell us that from the tabletop to the top of the incline is 0.5 meters. And they tell us that from the ground to the tabletop is 2 meters. And so, later in the problem, the block will slide off the incline, and A wants us to determine the acceleration as it slides down. But for now, let's just draw this as the block's velocity as it leaves the incline. This is the velocity vector of that, and we'll come back to that later. But for now, let's find the acceleration. To do that, all we'll do is sum up our forces in the x direction. And so we'll get mg sine theta equals mass times acceleration. Masses cancel out. All you're left with is a equals g sine theta. Plug in 9.8 for g and 30 degrees for theta, and you'll get acceleration in the x direction to be 4.90 meters per second squared. Part B wants to know what is the velocity of the block as it leaves the incline. So they want to know what's the velocity of the block as it leaves the incline right there. So what we can do is find the, since our axes are tilted, find the x velocity, the final x velocity here, and since it is just straight down, that x velocity, the x final velocity will actually be our answer. So to do this, we will use kinematics. So let's write out our givens. Here's in the x and in the y direction. Since it is released from rest, initial velocity is 0 for both x and y. And you know that acceleration in the x is 4.9 meters per second squared. And for y, it is simply g, because this is frictionless and it's like dropping a block in midair. So, you know the displacement from the tabletop to the top of the incline given by the problem, that is 0.5 meters. But using trig, you can find that, you know, the distance here is 1 meter. So, just real quick, that proves it. That distance is 1 meter. So now we need to find the final velocity in the x direction to give us our answer for what is that velocity right there. So we'll use this kinematic equation to do just that. Vf squared equals vi squared plus 2a delta x. Initial velocity is 0, so that cancels out. I'm going to square both sides. And I'm going to plug in the numbers. So square root of 2 times 4.9 meters per second squared times 1 meter. This will give you a final velocity of 3.13 meters per second. So right here, this velocity vector turns out to be 3.13 meters per second. So using that, this is 3.13 cosine 30, because that angle is 30, and this turns out to be 3.13 sine 30. And so while we're at it, we might as well solve for time because one of the other parts does need it. So solving for time, we will use this equation, delta x equals VIT plus 1/2 AT squared. This part cancels out because initial velocity is 0. Then we can isolate time. So we'll get t equals 2 delta x divided by a all square root. And so plug your numbers in. 2 times 1 divided by 4.9 meters per second squared. Plug that in, and you will get 0.639 seconds. We will use that in the later part. Part C wants to know how far from the table will the block hit the floor. So they want to know what's this distance when it leaves the incline. Well, how far does it travel? So in order to do this, you want to find out the time it takes for the block to hit the ground from when it leaves the incline. So you want to find out that time from right there to there. So in order to do that, you will go back to your kinematic equations givens. I'm going to label this air x and air y. So basically that is the the information for when the block is in the air when it leaves the incline. So using the components, I will write them right here. And since acceleration is 0 in the x direction when it leaves the incline, final velocity is also 3.13 cosine 30. And initial velocity is 3.13 sine 30. So acceleration is g, and they also tell us that displacement in the y direction is 2 meters. I will use this kinematic equation to solve for time. Delta x equals VIT plus 1/2 AT squared. This is going to turn out to be a quadratic, so I'm going to rewrite it in a quadratic friendly manner, and I'm going to plug in my numbers. So half of g is 4.9 t squared, plus if you put that into your calculator, you will get 1.565. So 1.565 t. And then plus delta x in the y direction is 2 meters. Solve this quadratic and you'll get time equals 0.499 seconds. And so to find the horizontal distance traveled, all you have to do is take this time and multiply it by the velocity in the x direction. And since the velocity in the x direction doesn't change, this works. 4.99 seconds times 3.13 cosine 30. And your answer is the block travels 1.35 meters after it leaves the incline. Part D wants to know what time interval elapses between when the block is released and when it hits the floor. So it just wants the total time the block travels from the top all the way to the ground. So you just add up your time answers from what we found earlier and what we just did. And that will give you 1.14 seconds. And now part E. Does the mass of the block affect any of the above calculations? And that is no. And that is because this incline is frictionless. If it was not frictionless, you would have, if this had friction, you would have a force that is mu n. And n, the normal force, would be related to, it would be exactly the y component of the weight. And the weight is dependent on the mass. And since this is a frictionless incline, we have no friction, none of that matters. So your mass will not affect any of your calculations here. And as you see throughout this entire process, you don't really use mass here or there. So no. And that is problem number 62.